Okay, this video is about page 11 of the Honors Chemistry Notes packet. The topic for today is metallic bonds. We do not spend a ton of time on these because we would rather focus on covalent and ionic bonds, so this is really brief. So metallic bonds are going to happen between a metal plus a metal. It could be two of the same type of metal, for example, like two gold atoms. But basically what happens in a metallic bond is that metal nuclei are held together by free valency electrons moving through the structure. So if you take a look at this picture down here at the bottom of the page, you can see that there's a bunch of positively charged nuclei sitting there in a relatively ordered fashion. And then there are those little red or pinkish dots that are kind of floating around in those interstitial spaces, essentially. Okay, and so what's happening is those little pink dots are allowed to kind of move around and wherever they need to go. And so those positively charged nuclei are allowed to stay close to each other because there's those negative electrons flowing through there. So you don't really need to know much about them, honestly. Some examples in your daily life would be stainless steel. It's an iron alloy. An alloy is just a mixture of metals. If you have gold jewelry on right now, that is an example of a metallic bond. You have metals bonded to other metals. Finally, any sort of electronics, any sort of wiring you have in your house, that copper wire, Cu, again, is going to be experiencing some sort of metallic bonding. And again, here's just an image down here for you to help you understand what we're trying to illustrate when we're talking about this. Some properties of metallic bonds is that they are really good at conducting heat and electricity. I mean, if you think about it, when we cook food on the stove, we usually use a metal based pan because they can conduct and keep that heat more easily than other types of compounds. Additionally, substances participating in metallic bonds are really ductile, and what ductile means is that they are able to be drawn into a wire. So think about all the metal wires that you know about. This ability for those nuclei and electrons to kind of move around allows them to be this way. And then finally, the last property that you need to recognize is that they are malleable. So basically, malleability just means that they can be shaped however you want them to be shaped. So like gold foil is a great example. You can kind of hammer down that gold so that it will be flat. So that's really all you need to know. It's not really that deep.